Hello students, so welcome back to my video lecture 10 on S block elements. So we have to now in this video we will talk about the last chemical property of sodium hydroxide. That was left out in the previous video. That is with mercuric ions and ammonium ions. After that we will study two more important compounds of sodium, and the video will go on. The lecture series will go on with other compounds of alkali metals and alkaline earth metals. So let us understand the last chemical property of sodium hydroxide with mercurous ion and ammonium ion. Observe here guys, come on. What happens when sodium hydroxide reacts with mercuric ion Hg2 plus? Hg2 plus. Any idea? Yes, simple, very simple. Sodium hydroxide contains what? Na plus ions and OH minus ion. This cation will react with this anion, isn't it? The cation will react with this anion. So we have Hg 2 plus and OH minus. Just interchange the charge. Minus 1 charge here and plus 2 charge here. So what is the product form? The product is going to be what? HgOH twice. Mercuric hydroxide. Is it correct? Mercuric hydroxide, which is highly unstable compound. This is an highly unstable compound. Therefore this compound will break. This compound is going to decompose to form HgO plus H2O. That is mercuric oxide is formed. Mercuric oxide is going to be formed. Any doubts? So like this, when sodium hydroxide react with mercurous ion, first it forms an unstable compound, which is that mercuric hydroxide, which is an unstable compound. It breaks down to give mercuric oxide and water. Again, don't worry about balancing the reaction. Yes. Now lastly, what happens when sodium hydroxide reacts with ammonium ion? Yes. What happens when sodium hydroxide reacts with ammonium ion? Come on. Ammonium ion. Very simple. Again, Na plus. OH minus. Now, this cation, should react with this anion, isn't it? One positive charge, one negative charge. Yes. What is the product form then? NH4OH. What is it? Ammonium hydroxide. Again, ammonium hydroxide is also unstable compound. It is also unstable compound. This breaks down to give ammonia and water. Yes, ammonium hydroxide is an unstable compound which will break down into ammonia and water. So that's all with respect to the chemical properties of sodium hydroxide. So we have understood a wide variety of reactions of sodium hydroxide with amphoteric metals, with carbon dioxide, with sulfur, with halogens. These are important. These reactions are very, very, very important for in the perspective of your entrance examinations. Which are those? Reactions of sodium hydroxide with sulfur, with halogens. Hope you remember that we discussed two cases. Reaction of halogens with cold and dilute NaOH, hot and concentrated NaOH. There we have so many dissimilarities in the reaction. There are so many differences in the reaction. Please note those differences. And lastly, we discussed the reaction of sodium hydroxide with so many metal ions like ferric ions, chromium ions, manganese ion, nickel ions, copper ions, aluminium ions, isn't it, etc., etc. What is important is the colored compound that is formed. Iron ion reacts with sodium hydroxide to form a brown colored compound. Copper ion reacts with sodium hydroxide to form blue colored compound. Aluminium forms a white compound. Chromium forms a green colored compound. Then nickel will form again a green colored compound. So like that, iron will form a brown colored compound. Manganese will form a blue colored compound. Please remember the color of those compounds. And lastly, we discussed again two important reactions, one with mercuric ion and one with what? Ammonium ion. So that's all about sodium hydroxide, preparation of sodium hydroxide, physical properties of sodium hydroxide, and also chemical properties of sodium hydroxide. We have discussed it in detail, very detailed. Okay, now I'm going to go with the next compound of sodium. What is it? Okay, yes, I'll be going with again a very important compound of sodium. Okay, which one is that? Okay, this is nothing but, yes, this is nothing but the next compound of sodium, the second compound of sodium, that is called as Na2CO3. Okay, Na2CO3. Okay, by the way, what is Na2CO3 called as? Okay, yeah, what is the chemical name of Na2CO3? The chemical name of Na2CO3 is called as sodium carbonate. Okay, what is the common name of sodium carbonate? Common name of sodium carbonate. The common name of sodium carbonate is soda ash. Okay, the common name is soda ash. Okay, the chemical name of sodium carbonate is Na2CO3 is sodium carbonate, and the common name is soda ash. Look here, see, when sodium carbonate is associated with 10 water molecules, okay, this is called as hydrated sodium carbonate, or else we read this as sodium carbonate decahydrate. Okay, simply hydrated sodium carbonate. Okay, here water, 10 water molecules are the water of crystallization. Okay, yes, so this sodium carbonate decahydrate, this is called as washing soda. Okay, what is it called as? Washing soda. Understood? Okay, yes, so Na2CO3 chemical name sodium carbonate, common name soda ash. Okay, and Na2CO3, if it is associated with 10 water molecules, that is hydrated sodium carbonate, is okay, commonly known as washing soda. Now here also we have to understand the preparation of sodium carbonate, okay, physical properties of sodium carbonate, and the chemical properties of sodium carbonate. Okay, we don't have much about physical properties here, so let us not worry about physical properties. We will deal only with the preparations of sodium carbonate and the chemical properties of sodium carbonate. Okay, yes, now how do you prepare sodium carbonate? Okay, one method we have already learnt. One of the method. What is it? Okay, see, I told you, if sodium hydroxide or sodium oxide, okay, when they react with carbon dioxide, okay, obviously they're going to form what? Sodium carbonate. They form sodium carbonate. Okay, yes, isn't it? We have already learned these methods of preparation of carbonates. Okay, sodium carbonate. Okay, yes, but in our NCERT textbook, we have got a most easiest method, okay, and most beneficial method for the preparation of sodium carbonate. That method is called as Solvas process. That method is called as what? Solvas process. Okay, this method is called as which method? Solvas process. Okay, so whenever they'll ask you to write the preparation of sodium carbonate, please don't consider these. Okay, yes, so whenever they are talking about the preparation of sodium carbonate, you have to think about which process? Solvas process. Now how do you prepare, okay, sodium carbonate? By Solvas process. Okay, of course the sodium carbonate can also be prepared by those methods, but the most easiest method, the most beneficial method is supposed to be which process? Solvas process, which has been clearly mentioned in our NCERT textbook. Okay, now whenever you are talking about Solvas process for sodium carbonate, remember the CAB rule. Remember the CAB rule. What is CAB rule? Okay, so C stand for what? Calcium carbonate. Understood? C stands for calcium carbonate. A stands for ammonia. A stands for what? Ammonia. And B stands for brine solution. Okay, B stands for what? Brine solution. So in Solvas process, we're going to use these three compounds. Okay, one is calcium carbonate, ammonia, and brine solution. Brine solution. Are you getting my point? So whenever you are talking about Solvas process, please remember which rule? CAB rule. Okay, so C stands for what? Calcium carbonate, A stands for ammonia, and B stands for brine solution. By the way, what is brine solution? What is brine solution? Brine solution is nothing but aqueous sodium chloride solution. Okay, aqueous sodium chloride solution. That means when sodium chloride is dissolved in water, we call that solution as brine solution. Okay, particularly its concentration should be about 30%. Okay, 30% aqueous solution of sodium chloride. Okay, 30% aqueous solution of sodium chloride, okay, is called as brine solution. There is a difference between liquid sodium chloride and aqueous sodium chloride. There is a difference between liquid sodium chloride and aqueous sodium chloride. What is the difference? Liquid sodium chloride means molten sodium chloride. Okay, when sodium chloride melts, the molten sodium chloride is called as liquid sodium chloride. But if sodium chloride is dissolved in aqueous solution, okay, that means when sodium chloride is dissolved in water, that aqueous solution of sodium chloride is called as what? Brine solution. Brine solution. Understood? Okay, so what are the raw materials used for the preparation of sodium carbonate by Solvas process? The raw materials are calcium carbonate, okay, ammonia, and what? Brine solution. And brine solution. Understood? Okay, so shall we look into the preparation of sodium carbonate by Solvas process? We have got 3 or 4 steps. Okay, which are those 3 or 4 steps? Look at here. First step. In the first step, okay, so first let us take calcium carbonate. What is the formula for calcium carbonate? Yeah, it is CaCO3. Calcium carbonate in the first step decomposes to give calcium oxide and carbon dioxide. Calcium carbonate decomposes to give what? Calcium oxide and carbon dioxide. Carbon dioxide. Understood? This is the first step. Now, in the second step, okay, next raw material, ammonia reacts with this carbon dioxide. Okay, ammonia reacts with carbon dioxide to form ammonium. Okay, yes, ammonium, okay, bicarbonate. Okay, it will form what? Ammonium bicarbonate. Understood? Okay, in the first step, calcium carbonate decomposes to give calcium oxide and carbon dioxide. In the second step, ammonia is reacting with this carbon dioxide to form ammonium bicarbonate or ammonium hydrogen carbonate. Ammonium hydrogen carbonate. Understood? Okay, in the third step, what is going to happen? Okay, next, let us take the brine solution. The brine solution, that is aqueous sodium chloride solution. Aqueous sodium chloride solution. Okay, yeah, aqueous sodium chloride solution will react with this ammonium bicarbonate to form, okay, it might form what? Sodium bicarbonate. Okay, it will form what? Sodium bicarbonate and ammonium chloride. Okay, again interchange of ions, that's it. Okay, so in ammonium bicarbonate we have, okay, NH4 plus ion and HCO3 minus. In sodium chloride we have Na plus ion, Cl minus ion. Just interchange this. Okay, are you getting my point? Yes. So ammonium bicarbonate reacts with sodium, that is brine solution, to give sodium bicarbonate and ammonium chloride. Now in the last step, okay, sodium bicarbonate decomposes to give sodium carbonate, water, okay, and carbon dioxide. Look at here, what did we get? We got sodium carbonate. What is this process? This process is called as Solvas process. Which rule you going to apply? CAB rule. C stands for calcium carbonate, A stands for ammonia, B stands for brine solution. By the way, what is brine solution? Aqueous sodium chloride solution. When sodium chloride is dissolved in water, that solution is called as brine solution. Any doubts? Okay. Now, what are the steps here? In the first step, Calcium carbonate decomposes to give calcium oxide and carbon dioxide. In the second step, ammonia, the next raw material, combines with that carbon dioxide to form ammonium bicarbonate. Ammonium bicarbonate combines with the next raw material, that is the brine solution, to form sodium bicarbonate and ammonium chloride. In the last step, sodium bicarbonate decomposes to give sodium carbonate. We have understood that bicarbonates are unstable. They soon decompose to give what? Okay, yeah, carbonates. Okay, did we not understand this under the chemical properties, under the formation of carbonates and bicarbonates, when we discussed the general chemical properties of alkali metals and alkaline earth metals? Please watch my previous videos. Okay, so this is how, we prepare sodium carbonate by which process? Solvas process. Understood? Okay, any doubts with this? Now, okay, let us look into the chemical properties of okay, sodium carbonate. Okay, yes, let us study the chemical properties of sodium carbonate. Okay, yes, now chemical properties of what? Sodium carbonate. Chemical properties. See, under chemical properties, okay, we just have to, okay, understand the reactions of, okay, sodium carbonate. First one with SiO2, silicon dioxide. Okay, silica, this is called as silica. Next one with HCl, and next one with water. Please, just 3 reactions, no such big deal here. Okay, so we will just study only 3 reactions of sodium carbonate. Which are those 3 reactions of sodium carbonate with silica, with hydrogen chloride, and with water. Now, what happens when, okay, yes, sodium carbonate, okay, yes, I'm talking about the first reaction. What happens when sodium carbonate reacts with silica, SiO2? Okay, yes. Okay, what is that? Whenever you are writing a reaction, what is that you're going to do? You will interchange the reaction. You will interchange the ions, isn't it? How many times should I have to tell? Should I have to tell you? Should I have to keep telling you each and every time? No, it's not required. That should come into your mind. Okay, so whenever you are writing this reaction, please interchange the ions. In sodium carbonate, which are the ions? In sodium carbonate, we have sodium ion and carbonate ion, CO3 2 minus ion, CO3 2 minus ion. But silica is a covalent compound. It does not ionize. Silica is a covalent compound. It does not ionize. What have I told you when you come across a covalent compound? When you have a covalent compound in a reaction, you just dissolve this covalent compound in water. Okay? Yes, isn't it? When you dissolve, okay, covalent compound in water, see what is formed. Okay, what happens when silica, okay, is dissolved in water? It will form, okay, yes, H2SiO3. Okay, yes, sodium silate, sorry, okay, yes, silicic acid, we call it as what? Silicic acid, okay, H2SiO3. Now, which are the ions present in silicic acid? The ions that are present in silicic acid is H plus ion and SiO3 2 minus. Okay, isn't it? Okay, are you able to understand? Silica is a covalent compound. Okay, it does not ionize. Therefore, whenever you come across a covalent compound in a reaction, dissolve it in water. When silica is dissolved in water, it will form silicic acid, H2SiO3. Now it will ionize. It will ionize to give what? H plus ions and silicic ions, SiO3 2 minus. Now can you interchange the reactions? Now can you interchange the ions? Okay, you will make this cation to react with this anion, and this cation to react with what? This anion, isn't it? Therefore, what are the products formed? Okay, so we have Na plus ion and SiO3 2 minus ion. Okay, just cross multiply, crisscross method. Okay, what is the product formed? Na2SiO3 plus, come on, okay, H plus CO3 2 minus, come on, cross multiply, 2 minus H plus, crisscross method. That means I'll be getting what? H2CO3. Okay, what is this? Sodium silicate. What is this? Carbonic acid. Carbonic acid. Okay, this is how we write the reaction. I hope you understood. Therefore, I can conclude that when sodium carbonate reacts with silica, it forms sodium silicate and carbonic acid. Okay, hope you have understood the course of the reaction. Yes, any doubts with this? Okay, fine. Now, let us go with the next reaction. Okay, what is the next reaction? Reaction of sodium carbonate with HCl. With HCl. Understood? Okay, yes. What happens when sodium carbonate reacts with HCl? React with HCl. Okay, yes. What are the products formed? See, okay, when sodium carbonate reacts with HCl, what might be the product? The products are, okay, yes, sodium chloride and sodium bicarbonate. Okay, sodium chloride and sodium bicarbonate. Sodium bicarbonate. Are you getting my point? Okay, again the sodium bicarbonate reacts with HCl to form what? Sodium chloride, okay, water and carbon dioxide. Water and carbon dioxide. Okay, but if sodium chloride, so that is sodium carbonate, is treated with excess of hydrogen chloride. Okay, excess of hydrogen chloride. Okay, if sodium carbonate is treated with excess of sodium hydrogen chloride, the reaction does not go in two steps. The reaction gets completed in one step. What is it? Sodium carbonate reacts with HCl, interchange the ions to form what? Okay, sodium chloride, okay, yes, water and carbon dioxide. Sodium chloride, water and carbon dioxide. Hope you understood. Okay, if sodium chloride is treated with excess of hydrogen chloride, it is going to form sodium chloride, water and carbon dioxide. Any doubts with these guys? Okay, so this is how sodium carbonate reacts with silica, and this is how sodium carbonate reacts with what? HCl. Okay, simple? Yes, that's so nice. Now last, okay, what happens when sodium carbonate reacts with water? Okay, what happens when sodium carbonate reacts with water? Very simple. Okay, yes, see this. Okay, what happens when the last reaction, when sodium carbonate reacts with H2O, that is water consists of H plus ion and OH minus ion. Okay, see, we have sodium ion and hydroxyl ion, correct? Sodium ion and hydroxyl ion, am I correct? This sodium ion combines with hydroxyl ion to form what? Sodium hydroxide. Okay, again we have hydrogen and oxygen, it will form what? Water. And then we have carbon and oxygen, it will form what? Carbon dioxide. So that means when sodium carbonate reacts with water, that is nothing but what? H2O. Okay, when sodium carbonate reacts with water, it will form sodium hydroxide, water and carbon dioxide. Such a simple reaction. So what is that you're going to remember here under sodium carbonate? It is its preparation. That is what is most important here. Okay, so which is the method of preparation of sodium carbonate? It is Solvas process. Okay, Solvas process, isn't it? Okay, so now with this we will go with the next compound of sodium, that is called as sodium thiosulfate. Okay, so now we'll go with the other compound of sodium, which is that compound, okay, the third compound of sodium. So far we have finished, okay, preparation and properties of sodium hydroxide. Okay, then preparation and properties of sodium carbonate. Okay, now we shall understand, okay, the preparation and properties of the next compound of sodium, that is called as Na2S2O3. Na2S2O3. By the way, what is the chemical name of Na2S2O3? This is called as sodium thiosulfate. Okay, this is called as sodium thiosulfate. But when Na2 S2O3 is associated with 10 water molecules. 10 water molecules. That means hydrated sodium thiosulfate has given a special name. The name of this compound is called as hypo. This compound is called as what? Hypo. Hydrated sodium thiosulfate is called as hypo. Understood? Okay. Sure. Now, what is that we're going to study here? Yes. Okay. We will study. Yes. We will study the preparation of sodium thiosulfate, which we have already finished. Okay, in the preparation of sodium sulfate is actually the chemical reaction of some other compound. What is that? I'll let you know. Okay, yes, we have already finished. Then we will study the use of sodium thiosulfate in iodometric titration. Iodometric titrations. Okay, then we will study the reaction of sodium thiosulfate with silver ions, Ag+, and we will study the reaction of sodium thiosulfate with chlorine or bromine water. Which we will use in our practical classes, that is called a salt analysis. Okay, in salt analysis we will use this. Now, yes, now how about the preparation of sodium thiosulfate? Okay, yes, I told you that we have already finished this preparation. Where did we finish this preparation? Okay, hope you remember one of the chemical property of sodium hydroxide. Okay, that is what happens when sodium hydroxide reacts with sulfur. Okay, I think we have already done with the various aspects of this reaction. What is it? I have told you that this is an example for disproportionation reaction, isn't it? When sodium hydroxide reacts with sulfur, the oxidation state of sulfur is in 0. Okay, the oxidation state of sulfur is 0. Whenever I have told you, whenever in a reaction, if you come across a reactant in 0 oxidation state, then obviously the reaction is going to be a disproportionation reaction. What do you mean by a disproportionation reaction? Okay, in the same reaction, the same element will be both oxidized as well as reduced, isn't it? Okay, so in this case, so sulfur will be both oxidized as well as reduced. Sulfur will be oxidized to sodium, sulfur will be oxidized to sodium thiosulfate. Sodium will be reduced to sodium sulfide plus water. Okay, it's an example for what? Disproportionation reaction. Sulfur from here to here, it is oxidized. Okay, because here the oxidation state of sulfur is going to be +2. From here to here, it is reduced because the oxidation state of sulfur is going to be -2. So this is both. Now it involves both oxidation as well as reduction of the same element. So what type of reaction is it? It's an example for disproportionation reaction. This is the second time we are studying this reaction. Now what are the chemical properties of sodium thiosulfate, students? So now what about the chemical properties of sodium thiosulfite? You should remember that sodium thiosulfate is a very good reducing agent. It is a very good reducing agent. Well, sodium thiosulfate will reduce others, but itself gets oxidized. Are you getting my point? Sodium thiosulfate is a very good reducing agent. It's a wonderful reducing agent. It will reduce other species, but itself gets oxidized. When it gets oxidized, it will be oxidized to Na2S4O6. Na2S4O6. Are you getting my point? What was the oxidation state of sulfur in sodium thiosulfate? It was +2, isn't it? In Na2S4O6, the oxidation state of sulfur is going to be 2.5. Look at here. So whenever sodium thiosulfate acts as a reducing agent, it itself gets oxidized, and it will be oxidized to what? Na2S4O6. Na2S4O6. Understood? Here the oxidation state of sulfur in Na2S4O6 is going to be how much? It is 2.5. Now, let us look at iodometric titration. Yes, this is one of the important titration. See, in iodometric titration, look at here. Well, okay, sodium thiosulfite, now Na2S2O3, sodium thiosulfate will reduce iodine to iodide. Okay, it will reduce iodine to iodide, but itself gets oxidized to what? Na2, okay, S4O6. Are you getting my point? Isn't it? Okay, so sodium thiosulfate, okay, is reducing iodine to iodide, but itself getting oxidized to what? Na2S4O6. Okay, this reaction is called as, okay, this we come across in a titration called as what? Iodometric titration. Okay students, we shall continue with the other chemical properties of sodium thiosulfate in the next video. Thank you so much.